this. So the absolute value of t squared minus 2t minus 3 is two different things as we know. T squared minus 2t minus 3 if t squared minus 2t minus 3 is greater than or equal to 0. Or the opposite of t squared minus 2t minus 3 if the other one, t squared minus 2t minus 3 is less than 0. But I have to solve this inequality. I don't have to solve this one. What I don't get in here, it will be in here. This one does not ever have to be solved, but I have to solve that one. So what type of inequality is this? Anyone would like to tell us? Anyone?
Quadratic.
Thank you very much. Awesome. It is quadratic. We have to factor into t, what is it? T minus 3 and t plus 1. So t squared minus 3t minus 3 plus t. Am I correct? T squared, t minus 3. Yeah. Oh, good. So then t, I'm studying the sign, and then t minus 3, t plus 1. There are many methods here. You can use any method you like. I prefer this one because it's easier to explain. It's visual. So t is the variable in the problem. T minus 3 is 0 at 3. Is 0 at 3. And t plus 1 is 0 at negative 1. Both of them, if you graph them, if you don't have to graph them, just think in terms of a linear function with a positive slope from negative to positive, or just plug in numbers. So this is 0 and this is 0. The product will be 0 if any of these is 0. When I multiply two negatives, I multiply a negative by a positive and two positives. Positive, that's what I want. So I want this and this, which means I want this and this. So therefore, the absolute value of t squared minus 2t minus 3 is t squared minus 2t minus 3 if t is between negative infinity, negative 1, union 3 to infinity. T in the interval, negative infinity, negative 1, union 3 to infinity. And it's the opposite of t squared minus 2t minus 3. Of course, I don't have to. Whatever is not here, it will be here. If t is in the interval, negative 1, 3. No question. So now, I know that this is a sum of two integrals. The integral from 2, so it breaks at 3. So the integral from 2 to 3 of this, and from 3 to 4 of this. Because we have between 2 and 4, but there is a break at 3. Okay, 2 is here, from 2 to 3, and from 3 to 4, from two different functions. That's how we determine this. So then the total distance will be the sum of two integrals. Of course, dt. The first one, because we are talking about, again, the same, we're talking about 2 to 4. So I have 2 to 3 and 3 to 4. So 2 to 3 is from this. I don't like that negative. I'm going to put it outside. So t squared minus 2t minus 3. And from 3 to 4, 3 to 4 is here, so from that. So t squared minus 2t minus 3. Good? So negative t to the third over 3 minus 2, t squared over 2 minus 3t from 2 to 3, but plus t to the third over 3 minus 2, t squared over 2 minus 3t, but from 3 to 4. And when I calculate these integrals, I will get the total distance covered by the particle, and that must be guaranteed positive. If it's not positive, there is a boo-boo somewhere. The total distance cannot be negative. The displacement can be negative. So the particle can start here and end here. So the displacement will be negative. If it starts here and ends here, then the displacement is positive. But the total distance, if you cover this total distance, your odometer will always go up. Your odometer will never show negative 10,000 miles, right? So this sum has to be a positive number guaranteed. Okay, so let's see how we get that positive number. Okay, 27 over 3, correct my numbers, keep an eye on my numbers, please. So 27 over 3, that would be 9. These two go away, minus 9, minus 9. Really? Don't forget this has to stay outside for the first integral. Okay, minus, I plug in 2 now, minus 8/3, minus 4, minus 6. Okay, I'm doing this again. 27 over 3, 9, minus 9, minus 9, minus 8 over 3, minus 4, minus 6. Okay, plus. I plug in 4 now. 64 over 3, minus 16, minus 12, minus now. I plug in 3. 27 over 3, 9, minus 9, minus 9. Okay, so let's see what we get. These two are gone. Now I have minus 9, minus 8/3, and this is negative 10 with minus in front. These two are gone. Okay, so plus 64 over 3, and this is minus 28. But this one now is plus 9. Okay. Okay. So negative 9 plus 10 is 1. So minus 1 plus 8/3, because this was 1 but minus in front. Minus with minus will be positive. Plus 64/3, and this is minus 19. Negative 28 plus 9, negative 19. Please correct my numbers anytime, please. Okay, let's see what we have here. So this is negative 20. What is this? So this is 72. 72 divided by 3. That's divisible by 3. Do I have 72 here? Yes, I do. Okay, so negative 20 plus, so this is 24. So it's 4 meters. Okay, and the answer has to be positive. Good, that is the total change or net change theorem. Any questions? And that completes 5.4. So the last section is on the substitution rule. Now, can anyone tell us the difference between, we have a function, f of x, not f prime. So can anyone tell us the difference between the derivative of this function and the differential?
Derivative would be f prime, and then the differential would be the function times dx.
Very good. Awesome. Brilliant. Thank you very much. Great job. Thank you. I need this reminder for the substitution rule. What does the substitution rule mean, or what is it for? To make our life easier. If it doesn't, we shouldn't use it. Okay? So I'm going to jump directly to examples on integration using the substitution rule, first for indefinite and then for definite. First for indefinite integrals. Indefinite. Okay. I would like to choose from 9 through 54. I'll choose first and you'll choose the next one. Okay, I'd like to start with 11. So the integral from t to the third e to negative t to the fourth dt. Okay. Now, this looks difficult. It looks difficult, a difficult integral, indefinite integral, because I see a product of two functions. How do I differentiate a product? I have no idea. I wasn't taught yet. You have to wait till Calc 2. So maybe I can use a substitution. So this is our function. This is function f of t. So I want to use a substitution to make this function easier to handle and determine the integral from. And of course, this is a function, is the most general antiderivative, a family of functions, and it has to be in variable t. Okay. So I'm looking at this product. I see t to the third and I see e to negative t to the fourth. And personally, what bothers me, well, this is not a scientific way, but I'm just trying to teach you the simplest possible way to think about it. What I really don't like about this is not t to the third. That's a friendly polynomial. What I don't like is this e and the fact that it has a function in it. If it had just e to t, I can't do anything to it. But it has some sort of function that really is kind of scratching my eyes, right? It's a function inside a function. So I'm going to be on this path now. I'm going to say let u, any letter you want but t, u, y, z, whatever you want. So let u equal this. Negative t to the fourth. Only if the differential of u, which is du, which we just discussed, the derivative of this, minus 4t to the third dt, only if du is in the problem or very easy to make up. When I say very easy to make up, I'm only thinking about a number. This number is very easy to make up. How come? I'm going to multiply by 4 and divide by negative 4. I'm going to multiply by negative 4 and divide by negative 4. Nothing happened. If I multiply by negative 4 and divide by negative 4, I have 1. So the problem hasn't changed. The function hasn't changed. But why did I choose negative 4? Because of this. So negative 4 is there. Do I have t to the third? Yes, I do. Do I have dt? Yes, I do. So what I'm telling you is now this will be replaced by du. So I will have negative 1/4 in front. I will have these three factors that make up the du. But the question is what I replace this by. Can anyone tell us what do we replace this by?
U.
Careful. I didn't say anything about e. So it's e to u. I can't change e. E has to stay, right? U is only negative t to the fourth. Are you with me, everyone? Is this clear? We're going to have plenty of examples. That's what we're going to do for the next hour or more. Is this clear, what I just did? And how do I continue? Negative 1/4. What is the antiderivative of e to u?
E to u.
That's it, plus a constant c. The only thing is, this is an indefinite integral. It's not a number. And since the function, the initial function is in t, I have to go back. All I have to do is replace u by this. And it's finished. Done.
I have a question.
Yes.
Did you get 1/4 from the t raised to power 3?
So let's because I'm not sure what the question is. Let me just go back and rephrase. So I denoted by u, and please stop me when you think that that's the point where I should explain more. So negative t to the fourth is u. It's a new function. I found the differential of u. du equals negative 4. I know you are confused a little bit now because we have integration on our plate and differentiation on our plate.
Yeah.
So I'm not integrating this, right? I'm finding, yes, so that's why it's confusing. I know what, I know. I think that's the confusion, right? That's why I asked. Remember how to determine dy or the differential of a function. Du equals u prime times du, right? Or whatever this the function is. So here I have to differentiate to find the du in the problem.
The t cubed, was it integrated?
So negative 4 t to the third dt.
From like the first part, like, yes, right there, where you pointed before. Yeah, right there. T cubed. Like, what happens to that? Did you integrate
Very good,
it?
very good. Negative 4 t to the third and dt. These three pieces are du.
Oh.
Better? You're going to see this in the next 10 examples at least. But it's a very good question. So that's why I crossed them out with orange. Negative 4. That's why I needed to make up a negative 4 with a negative 1/4 in front. I cannot just put in a negative 4 without changing it, putting in front a negative 1/4 because this is 1. I didn't change the problem. I changed the outlook, the presentation of the function. So the negative 4 t to the third and dt, these three now are here. And e to u is e to u. E to negative t to the fourth is e to u. There is a negative 1/4 in front. And now this is so much easier to integrate than this. So the antiderivative of e to u is e to u. There is a negative 1/4 plus a constant c. Since it's an indefinite integral, the answer must be in the variable that the function was given in. These intermediate steps are for us to solve easier, to make our life easier or the integral easier. But at the very end, we have to go back to the variable that was used in the original function.